Assalamualaikum warahmatullahi wabarakatuh, and good afternoon everyone. So today we still have our YouTube class, and for today we will continue our chapter 4. Okay, we just finished our discussion on computer language, and we stopped at programming, okay, hybrid object based programming language. And for today, okay, we will continue with program translator. Okay, before we go more further on program translator, okay, we need to know what is program translator. Okay, program translator is a program that transform or translate source code into machine readable code. Okay, the keyword here is transform or translate. Okay, from program to code. Okay, that's mean, okay, this is a kind of program, okay, that convert, okay, our source code into what our computer understand. Okay, so actually we have 3 types of program translator. Okay, this include, first we have assembler. Okay, and this is for assembly language. Okay, okay, and then we have another type of program translator that we call it as compiler. Okay, for example, we have C++, okay, that use compiler. Okay, and then we have interpreter. Okay, for interpreter, for example, Java use interpreter. Okay, we will discuss, okay, one by one on what is assembler, what is compiler, and what is interpreter. Okay, after this, for the assembler, okay, it is a program, okay, that translate instruction. Okay, as I mentioned before, we have assembly language code into a form that computer can understand. Okay, what language that our computer understand? Just binary. Okay, 1010. Okay, so if you are doing coding, okay, so this is an example of coding in assembler language. Okay, and then this assembler convert what you doing here, okay, in program into binary. Okay, so we have an example on assembly language. Okay, what happened, okay, when we have assembly language, then we will look at the example in machine language. Okay, for your information, we will do learn in detail about the assembly language in our next chapter. Okay, don't worry about this, because this is just a simple example to give you a clear picture, okay, what is going when you are using assembler. Okay, for example, okay, very simple instruction that we have here. Okay, to add, okay, to do additional or plus operation. Okay, this add, okay, is known as the opcode. Okay, what is opcode? It's something that we use in high level language, okay, or Java. Okay, this is operation add. Okay, we want to add AX. Okay, AX actually is a register, or in other words, it is a kind of memory. Okay, and then this is operand. okay, operand. This is a value of additional, the value of operation that we want to do. Okay, in this case we want to add AS. Okay, we want to add 0010 into memory AS. Okay, and then 50, okay, 50 is opcode in machine language. Okay, then we have okay, sorry, so we just do this. Okay, we just do in add AS 0010 as our assembly language. Okay, then in machine, they will change into 05, okay, and 1000, okay, in machine language. Okay, so what happened right now? Okay, in assembly language we have moved AS 0005. Okay, and if you can see here in binary, they will becomes this. Okay, or if you want to do or to look in hexadecimal, okay, we will have this. Okay, so in this case, the real code, okay, the real machine code here actually is machine language. Okay, so this is actually what happened when you are using program translator that we call as the assembler. Okay, we will discuss about compiler, okay, in our next slide. Okay, before we go to the compiler, okay, I forgot to mention about this. Okay, so in our programming in assembly language, we understand about add, AS, and 0010. Okay, we do this. Okay, but in machine, add will be translated as 05. Okay, this is opcode that machine language no. Okay, but we as human, we use add. Okay, so 05, okay, we will convert into binary. Okay, and if you can see here, okay, in machine language, okay, if you see, you can see here the operand here. Okay, we have 1 and 2. Okay, 1 for AS, operand 2 is 0010, becomes interchange. Okay, that's mean if we have 1 and 2, okay, this is 1, this 2, okay, operand 1, 1, 2, but in machine language it's become 2 and 1. Okay, this happen because the machine read from left to right. Okay, so I hope you can understand this, and not need to understand how can we convert here 005 to binary, AS to binary, no. Okay, but you need to understand the how assembler here is used. Okay, how assembler is works actually. Okay, our second program translator, okay, after assembler, here we have what we call as the compiler. Okay, compiler is compiler here translates a program in a programming language. Okay, so the function is same, okay, with the assembler and interpreter, okay, as to translate, okay, from the source code to machine code. Okay, so what happened in compiler, okay, when we do programming, okay, we call it as the source code. Okay, the program is called as a source code. Okay, when we use compiler, okay, that's mean we compile the program, we translate the source code into what we call as the object code. Okay, if in assembler, okay, from assembly language to machine code, but in compiler, what we have here is the result, okay, the output from the compiler is object code. Okay, so how does compiler compile a program? Okay, so when we have source code, okay, source code is read, okay, from a file by compiler, and object code is written to newly created file. Okay, so for example here, okay, we have .java. Okay, .java program is our source code. Okay, and each of programming language have its own dot. Okay, for Java we have .java, and when we compile, okay, in Java using compiler, okay, that's in Java we have Java C, right? JavaX to compile, and C here is referring to compiler. Okay, when we compile the object code with o.o or .ofg will be generated. Okay, and maybe some of you confused about my statement before. Okay, what I told you before, I told that the Java is using interpreter, right? And the C use compiler. Okay, actually in Java, Java use two, both Java compiler and also interpreter. Okay, okay, as I mentioned before, JAVC is Java compiler. Okay, and Java Virtual Machine, okay, JVM, okay, this is Java interpreter. Okay, so why I say that Java use interpreter? Okay, because Java, okay, use interpreter to execute, okay, to execute the object code, okay, not directly from source code to execute code, okay, to run. Okay, so I hope you understand about this. But okay, for the C, is totally use compiler. Okay, so I hope that this not give you confusing. Okay, but just need to know that in Java program we have both, okay, compiler and interpreter. Okay, another things that you need to know, for the compiler, okay, our source code statement are read into the compiler one at a time. Okay, one at a time. So the compiler will read all. Okay, it is different with the interpreter, which is we will discuss it later. Okay, and another thing is three classes of source code statement. Okay, if you are using your coding, okay, in your coding, okay, we will have what we call as first data declaration. Okay, that's mean you declare the variable that you use. Okay, and then the operation that you need to do. Okay, declaration, operation, and control structure. Control structure means we have if, then, okay, for, and so on. Okay, data operation, maybe you have plus, minus, okay, and so on. Data section if, okay, go to, and so on. Okay, data creation, you define, okay, variable what, okay, maybe variable integer, okay, for x, y. Okay, so we have another two, okay, two others, which is we will discuss about these two. Okay, in these two, it is actually support libraries, and also in compiler or in source code statement, we need to have linking. Okay, so we will going to discuss, okay, about the what we have in data collection, data operation, control structure, support library, and linking. Okay, after this. Okay, so for the data declaration, why we need to have the data declaration? Because it will set, okay, set the memory location. Okay, for what? For store, okay, to store, okay, to store our information of our coding. Okay, so by data declaration, we set, okay, here memory location to store the declared data. Okay, when we have memory location, okay, that's mean, okay, we know the amounts of memory allocated. Okay, and this will depend on data. Okay, for example, if we declare integer, okay, we will have certain location for memory. If you are using real, we have certain range of memory that provided, okay, by our computer, and character. Okay, for example, if you are using character, okay, maybe the space here is less, okay, than if you are using string. Okay, I hope that you can understand this. Okay, and in this process also, okay, compiler builds internal table. Okay, this internal table also known as symbol table. Okay, this is to keep track the data names, types, and assign memory address. Okay, so let's say we have here table, okay, something like this. Okay, so we have variable what, okay, names, and we have memory information from range what to what. Okay, okay, we also have data operation. Okay, as data operation are encountered in source code, they are translated into sequence of machine instruction necessary to implement those operations. Okay, so for data operation, we have maybe sequence of instruction that need to be run, okay, to be run by our machine. Okay, for example, 1, 2, 3, 4. Okay, and we have in sequence. Okay, in sequence, and these instruction sequences include primitive data manipulation instruction, as well as any necessary data movement instruction. Okay, so we have data, okay, data instruction, manipulation instruction, and so on. Okay, Data movement means, okay, if you using go to, okay, so they move, okay, our data. Okay, in our source code also we have what we call as the control structure. Okay, as I mentioned before, we have if, for example, go to, okay, go to as an example of control structure. Okay, go to, okay, go to means it is a kind of unconditional branch statement of subroutine. Okay, what is conditional branch? Okay, this for example, we have if then else, okay, and also loop, okay, under the conditional branch. Okay, for the support libraries, when we have object code, this object code consists entirely executable mission code or mission instruction and data. Okay, data means, okay, we have what we call as the executable code. Okay, what is the executable code, or sometimes we call it as the internal subroutine? Okay, this is a certain type of language statement, okay, including data declaration, control structure. Okay, when we convert this, okay, we will get the executable code. Okay, this external subroutine or executable code, okay, can be found in either one of these places. Okay, that's mean the external subroutine. Okay, that's mean we have outside our code, okay, can be found in maybe compiler, library, and library call. Okay, maybe you also have experience in doing coding, right? Sometimes when you compile, the compiler tell you that no library found it. Okay, that's possible. Okay, so we will look at the support library. Okay, support library. After this. Okay, when you compile your programs, okay, usually, okay, we need to also do what we call as the linking. Okay, why we need to have a linking process? Because preceding library call is not in CPU instruction. Okay, maybe, okay, your program call outside library. Okay, library, what is library? It's not our library. Okay, this kind of file. Okay, for example, we have DLL file. Okay, that referring to library. Okay, this library, okay, library call is called a reference to set the executable code that have been previously compiled and stored in the library for later use. Okay, for example, the company, okay, for the compiler give you a library. Okay, this library can be used, okay, and we need to refer to the documentation. Okay, how can we call the library? Okay, so calling this library need the process of linking. Okay, and then therefore it must be replaced by the corresponding library code before application can be executed. Okay, so we need to do linking and replace, okay, by corresponding library when the source code, your source code called the library, okay, they will replace, okay, by the corresponding library before the application can be executed. Okay, a program called as the linker, okay, or link editor perform this replacement. Okay, so when your program called the library, okay, we have program linker or link editor that perform the replacement. Okay, the process of replacement is called linking, link editing, or binding. Okay, so I hope this is clear. Okay, when you are doing your program, it's not just compile, okay, but the compiler also need to find library. Okay, this process of find library called as the linking. Okay, so we will discuss, okay, our last type of program translator that called as the interpreter after this. Okay, so I think that's all, okay, for today. I hope you can understand, okay, what we have in chapter 4. Okay, thank you for your attention. Thank you for attention. Okay, that's all, okay, for today. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.